Hello students, welcome back. I hope you are doing good. So in today's part, I will be discussing about all the general concepts of your aldehydes and ketones, like what is the IUPAC nomenclature of your aldehyde, what is your IUPAC nomenclature of your ketone, your general names of your aldehydes and ketones. And at the ending, I will be discussing about the physical properties of your aldehydes and ketones. So why to waste time, students? Let's start with our part. So introduction. So, aldehydes and ketones are also called as your carbonyl compounds. So, aldehydes and ketones can be classified as carbonyl compounds, and you can see here in the above table there is a class in the sense, for example, which class ketones is a class, aldehydes is a class, carboxylic acids is a class, acid chlorides is another class, esters and amides are also comes under some different classes, right? And ketones, you can see here the general formula RCOR dash. I mean, there is an alkyl group here, there is an alkyl group here around carbon, right? And aldehyde RCO, instead of an alkyl group here you have an hydrogen. This is important, right? Instead of an alkyl group you have the hydrogen. So that's what the difference between your ketone and your aldehyde. So the difference is, for ketone at one end you have an alkyl group, and for aldehyde you have an hydrogen, and for carboxylic acids you have an alcoholic group, right? And for acid chlorides you have a chloride group. Esters you have OR minus group, and for amide you have NH2. So thus these comes under the set of carbonyl compounds. All these are the carbonyl compounds, not only aldehydes and ketones. The remaining are also called carbonyl compounds. The logic is you have a carbonyl group here which is RCO, so which is a carbonyl compound, and to that there will be a functional group, I can say. So here the functional group is a alkyl group, here the functional group can be hydrogen, and you can have different functional groups like your alcohol, your halide, your NH2, and you have your OR minus. So these comes under the set of carbonyl compounds. So carbonyl structure, what do you think will be the carbonyl structure, right? You know that RCOR dash and RCOH is your general formula for your aldehyde and ketone, right? Now what can be the structure? So the first important thing is, in RCO the carbon is sp2. This carbon is an sp2 hybridized carbon. That is the first important point. Second important point is that your CO bond is shorter, stronger and more polar than CC bond in alkenes. For example, now I am comparing here my carbonyl compound or carbonyl carbon with an alkene. So for example, if I have RCO R dash, a ketone, and I have RCC R dash. The same thing, right? I have R and R dash here and I have R dash here, but here I have a CO which is a carbonyl, and here I have an alkene. So the important thing is that my CO bond here is shorter and stronger. Why? Because of the higher interatomic attractions between carbon and oxygen. Why? Because there are lone pairs on oxygen, there are lone pair of electrons on oxygen, which actually increases the bond strength. And if the bond strength is higher, you know that your bond length will be shorter. Yes, my bond length is shorter and more polar. Exactly, if the bond is shorter as well as stronger, it becomes more polar, right? So compared to a CC bond in alkane, CO bond is dash shorter and stronger. So you can see here, you can see the structure of a carbonyl. So you can see here there is an R dash. So you know that oxygen has lone pair of electrons, and not only that, you can see that, you can see the formation of pi bond here. So in ketone, for example, this R and R dash is a ketone. The bond length of CO is 1.23 angstroms, and your bond length in alkene is 1.34. So you can say that 1.23 is less than 1.34. So I can also say that my bond length is decreasing, my bond length is shorter. And you can also compare the bond energy. The bond energy is around 178 kilocal per mole here for ketone, but for an alkene it is 146. So I can say that my ketone has higher bond energy and lower bond length compared to an alkene. So next, so it is very important to name a given entity, right? Each and every entity in the universe has certain name. For example, our country, for example, has a name that is India, isn't it? So just like this digital pen, so it has a particular name. So what about an organic compound? An organic compound should also have certain name, isn't it? And especially aldehydes. We'll look specially about aldehydes. So aldehydes should also have certain name. And you know that organic compounds are given names under the IUPAC system, right? So let's study about the different IUPAC names for aldehydes. So what you will do is replace E with al. So what does that it meant? It means that, for example, if we have an alkane, so an alkane has E at the end. So you replace this with al. So I will be getting alkanal, right? I will be getting an alkanal. For example, I have butane. I will be replacing E with al. So it will be butanal, right? So replace E with al. So the aldehyde, al comes from aldehyde, al. Right, this Al and this Al are same. So the aldehyde carbon is number 1. So while naming your given organic compound, your aldehyde carbon should be given the first preference. So now if your aldehyde group is attached to a ring, you have to use the suffix carbaldehyde. This is also another important point. For example, you have this, your aldehyde CHO is attached to the benzene ring. So now what you have to use? You have to use the name aldehyde, right? Carbaldehyde. So here it will be, since it is a benzene, it will be a benzaldehyde. This is also an important point. So if you select a parent chain, what is parent chain? Parent chain is nothing but your longest continuous carbon chain containing the carbonyl group. So in a parent chain, just like I already told you, you have butane, and butane is a parent chain of 4 carbons, and which is the longest chain. And in butane, just like you are replacing E with al, in any longest chain carbon chain, longest continuous carbon chain, you have to replace your E with al. And remember, the first preference is given to your carbon consisting of this aldehyde functional group. So how do you name aldehydes? I told you, just replace E with al. The aldehyde carbon is number 1, and if it is attached to the ring, you have to use the suffix carbaldehyde. For examples, here you have this given organic compound, and you have to select the longest carbon chain, and yes, I will select this longest carbon chain, and I have to select this as the carbon 1 as the primary carbon. So it will be 1, 2, 3, 4, 5. So since it will be now, for example, if it is 1, 2, 3, if it is having 5 carbons, it is obviously pentane. So I have to replace E with al. So pentanal, it will be some pentanal. Not only that, at the third position, you have a substituent of your methyl group. So what I can say, it is now 3-methyl pentanal, right? Because at the third position I have a methyl group and have a 5 carbon aldehyde, so it will be 3 methyl pentanol. Now what about this? You know that now here aldehyde group is attached to a cyclic ring, and you know that it will be a carbaldehyde, right? Because aldehyde group attached to a ring will be named as a carbaldehyde. The same thing here. Here you have a carbaldehyde. Not only that, you have a cyclopentene, and why 2 is given there? Why 2 is given? Because this is your first carbon to which your functional group is attached. So remember, this is a functional group. So I will start my numbering from here, and so it will be 2. So 1, 2 and so on. So it will be 2 cyclopentene carbaldehyde, since this is a carbaldehyde. So let's study about the common names of aldehydes. So use the common name of the acid. For example, you drop ic acid and add aldehyde, right? Now this is a common name. Here this is a common name, not the IUPAC name. So in the common name, just drop ic acid by aldehyde. For example, you have formic acid, and for formic acid you have to just write it as formaldehyde, since you are dropping ic acid to aldehyde and you are adding ic acid and replacing it with aldehyde. So if I have a formic acid, I will replace ic acid by aldehyde, so it will be formaldehyde. And 2 carbons, if you have 2 carbons, you know you have acetic acid, and if it is an acetic acid, I will replace ic acid by again aldehyde, so it will be acetaldehyde. 3 carbons, propanoic acid, it will be your propanaldehyde. 4 carbons, obviously you know it is a butyric acid, so you will be replacing by aldehyde, it will be butyraldehyde. So now we will move on to the IUPAC name of ketones. So just like aldehydes you replace E with al, for ketones you replace E with on. So you have to select the longest carbon chain, and you have to number the carbon chain with your carbon as the first preference, carbon consisting the ketone. For example, you have this, and in this you have to start with your carbon. For example, you have 1, 2, 3, 4. So you have to start from this position, since your carbon has the carbon with this functional group of carbonyl compound or carbonyl compound. This is actually carbonyl carbon, right? So this carbonyl carbon is actually given the lowest number, right, since it is 2. If I start it from here, it will be 1, 2 and 3. So here the carbonyl carbon is given the lowest number. So I have to start from here. So for cyclic ketone, just like you are given an idea about cyclic aldehydes, for cyclic ketones the carbonyl carbon is assigned the number 1. So you know that, you know this. If it has a parent, so parent select the longest carbon chain. Again the same rule which was given to aldehydes. So drop E and add on. Let's discuss some examples. For example, you have this. So you have to start your numbering from this 1, 2, 3 and 4, and so it is 3-methyl-2-butadiene. How? You know that I have to select the carbonyl carbon with the least number. So if I start from right to left, it will be getting a third position, and if I start from left to right, it will be getting a second position, isn't it? Let me start with right to left once. So it will be 1, first carbon, second carbon, third carbon and fourth carbon. So if I start from right, it will be the third carbon, but if I start from left, it is the second carbon. So I have to select that sequence where my carbon is getting the least number. So I will be selecting this carbon. So if I start from this carbon, you know that at third position you have methyl group. So it will be 3-methyl-2-butanone. Similarly, this cyclic compound, you have to start numbering from that carbon for cyclic where your carbonyl carbon is present. So it will be 1, 2 and 3. So it will be 3-bromocyclohexane. Similarly, this here you have to select again that carbon where this is given the minimum number, so it will be 1, 2, 3, 4. So it will be 4 hydroxy, 3 methyl and 2 butanone. Now, if the ketone is present as a substituent, what it will be? It will be now written as your oxo, right? For example, you have CO group, your keto group is oxo. What is the substituent, right? For example, you have this kind of compound. Here, your keto group is a substituent because my carboxylic acid is a primary group. So, if there is a primary group and your ketone is a secondary group, or it is called also a substituent, and if it is a substituent, it will be given certain name. And for example, here your keto group is called an oxo and the aldehyde is a formal. So, it depends on the highest priority functional group. For example, your carboxylic acid is a higher priority functional group, that's why keto is given an oxo and aldehyde is formal. So, aldehyde priority is higher than ketone. This is also very important. For example, if you have RCOCH2COH, here in this compound you have an aldehyde and a ketone. So, aldehyde priority is higher than ketone. This is very important. So, I have to start my numbering from here to here. Right to left instead of left to right. So, for example, you got this structure. So, the name will be what? The name will be 3-methyl 4-oxopentanol, right? So, because I have to start my numbering from here 1, 2, 3, 4, 5, and here it will be obviously 5 carbon, so it will be pentanol, because I will be replacing E with al, so it will be pentanol. Not only pentanol, I have to mind that at the third position there is a methyl group, so it will be 3-methyl, and I have to also mind that at the fourth position I have a keto group, that means it will be 4-oxo. Why? Because my ketone has a name of oxo if it is not a primary functional group. Same thing with here. Here you have a carboxylic acid and here you have a carboxylic acid. So, the first preference will be the carboxylic acid and next preference will be your aldehyde. So, you will be having 3-formal benzoic acid because your aldehyde is a formal. So, it will be 1, 2, 3. So, 3-formal and this remaining is a benzoic acid. So, what are the common names for the ketones? Just like aldehydes, you know the common names. Ketones also has certain common names. So, the common names, for example, you can see here, this is methyl isopropyl ketone, right? So, it is named as an alkyl attachment to CO, or which is your carbonyl carbon, and you can see here it will be methyl isopropyl ketone, right? It's a common name. I am not using IUPAC system here because here I am not mentioning this as, for example, 1, 2, 3 methyl, right, butanone. Instead of this, I am just writing as methyl isopropyl ketone. Similarly, this I am just write this is a common name. In a common language. This is also you have your alpha bromomethyl, because why alpha? Because alpha is that carbon which is attached to a functional group. So, that is the functional carbon. So, this will take the alpha position. So, it will be alpha bromoethyl isopropyl ketone. And historical common names. So, this is acetone. This is famous, right? You already know it. This is acetophenone, right? Because you have a keto group on your benzene ring. So, it will be acetophenone. So, what is this? Here you have a keto group, there is a benzene ring here and benzene ring here. So, what will be that? Name will be benzophenone, right? Because this is a phenone and this is a benzene ring. So, it will be a benzophenone. Now, physical properties. So, some of the physical properties are listed here. Boiling point and melting point. So, here you can see here boiling point and melting point always increases with the increase in the surface area of a given structure. That is the first important point. And here I am comparing my boiling point between an alkane, this is an alkane, this is an aldehyde or ketone, and you have an alcohol. So for example, the molecular weights are almost same. The molecular weights is almost same. Here 72, here 74 for alcohol, and for 72 for your hydrocarbon. So for compounds of comparable molecular weight, boiling point and melting point usually follows this trend. How? You know that boiling point and melting point depends on the intermolecular forces. So here also the same thing, intermolecular forces. So increasing strength of intermolecular forces increases the boiling point, right? Because alcohols have stronger intermolecular forces than aldehydes and ketones compared to alkanes. Alkanes have less intermolecular forces. Coming into the solubility, right? So you can see here aldehydes and ketones are soluble in organic solvents. That is a fact that your aldehyde and ketone are very much soluble in organic solvents. And next important, this point is important. Why? Because if your aldehyde and ketones have less than 5 carbons, they are water soluble. Why? Because if they are having less carbons, they can form a hydrogen bond. And if you have greater carbons, they are insoluble because non-polar alkyl portion comes into the picture and it is very difficult to dissolve in the polar H2O solvent. So you can keep in mind that yes, there is a limitation for your aldehyde and ketone for the solubility. And yes, my boiling and melting point depends on the intermolecular forces. So I can say that my aldehyde or ketone has less boiling point and melting point compared to your alcohol. And also remember one important technique that, for example, I have a similar kind of aldehyde. For example, I have propanol, I have butanol and pentanol, and someone asks which one is having higher boiling point or higher melting point. So always remember your pentanol has higher boiling point and melting point because this has higher surface area compared to butanol and propanol, because higher surface is nothing but higher number of carbon atoms. Now a concept check. So this is actually the end to your introduction. So let's end it with the concept check. So I want the IUPAC names for the given compounds. What do you think is IUPAC name for the given compounds? I'll be giving 30 seconds. Think about it. And based on the logic which we have studied from the previous concepts, let's come to the conclusion. So I'll be giving you 30 seconds. Think carefully and answer, okay? IUPAC name, not common name. So you know that the first thing is actually aldehyde, and second thing is also an aldehyde because you have CHO group. So based on that we can build. 15 seconds finished and we have last 15 seconds student, so think about it. And yes, last 5 seconds, 5, 4, 3, 2 and 1, time's up. I think you got an answer for this, right? The first one is an aldehyde, and you know that it's an ethane. From ethane I will be replacing E with al, so it will be ethanol. So the first will be an ethanol, because it will be an ethane. If I don't have this, since there are 2 carbons, it will be ethane. I will be replacing E with al, so it will be ethanol. Here also remember that instead of hydrogens I have phenyl groups. Instead of hydrogens I have phenyl groups. So you know that phenyl groups are acting as substituents there. So you know this is already an ethanol because it's an ethane, and here it's ethanol, but here you have 2 hydrogens attached to this carbon, but here you don't have hydrogens, they are called phenyls. So it will be 2,2 diphenyl ethanol, because this is a phenyl group, this is a phenyl group. Instead of your hydrogens on ethanol, CH3 and CO, instead of hydrogens you have phenyl group, so it is 2,2 diphenyl ethanol. So students, these are the basic concepts of your aldehydes and ketones. So we have discussed about the structure of aldehyde and ketone, we have discussed about the naming of your aldehyde and ketone, and at last we discussed about the physical properties, right? And also we have solved 2 concept checks, and I hope and I believe that you understand those questions. So in our next part, we will be discussing about your general methods of preparations of your aldehydes and ketones, right? So till then, stay tuned to our sessions. Take care. Goodbye.